If you deploy your brand new application to the cloud, but your users complain it takes forever to load, you probably put your data in the wrong place. The cloud still has a physical location. Today, we're breaking down the physical architecture of AWS, regions versus availability zones. When we say the cloud, we're not talking about something abstract floating everywhere. We're talking about Amazon's real physical data centers, huge buildings full of servers, power systems, and network cables. AWS organizes all of this hardware using two key concepts: regions and availability zones. Start with regions. A region is a large, clearly defined geographic area. Think Northern Virginia, London, or Tokyo. When you choose a region, you're choosing where in the world your application will live. That choice affects how fast your app feels to users, because data still has to travel across real distances. A user in London talking to servers in London will get a much faster response than a user in London talking to servers in Australia. That distance turns into latency, and latency turns into loading spinners and angry users. Inside every region are availability zones, usually called AZs. An availability zone is an actual physical data center, or sometimes a small cluster of data centers within that region. So when you select a region like Northern Virginia, you are not renting space in a single building. You are getting access to multiple distinct availability zones, usually labeled something like AZA, AZB, and AZC, all spread across that same geographic area. Here's the key distinction to lock in. A region is the where at a high level. An availability zone is the individual building where your servers actually run. So why does AWS bother splitting a region into multiple availability zones instead of building one giant data center? The answer is fault tolerance. Availability zones are intentionally isolated from each other. They're miles apart. They use separate power grids, separate internet connections, and they're built on separate floodplains. That means if something catastrophic happens, say a major storm, a power failure, or a networking outage, it can take down one availability zone without touching the others. Imagine AZA goes dark. If your application only lives there, it's offline. But if your application is spread across AZA, AZB, and AZC, traffic can automatically shift away from the failed zone. From the user's perspective, the app keeps working. This is one of the most important ideas in AWS, and it shows up constantly on exams. High availability in AWS comes from using multiple availability zones, not from buying bigger servers. Now let's talk about how this works in practice. In the real world, you should never deploy a production application into just one availability zone. Instead, you design for multiple AZs from the start. For example, you might run your web servers in AZA and keep a synchronized database replica in AZB. If AZA fails, AZB is still alive and ready. You might be wondering if separating components like this makes things slower. It doesn't. AWS connects availability zones within a region using dedicated ultra-high-speed fiber optic networks. Data moves between AZs in milliseconds. To your users, it feels like everything is sitting in the same room, even though it's physically separated for safety. That combination is the magic of AWS's physical design. Regions keep your application close to your users. Availability zones keep your application running when hardware fails, buildings lose power, or disasters strike. Now that you know where Amazon's physical data centers actually are, the next question is how you isolate and protect your own slice of them. To learn how to draw a secure, invisible fence around your resources, click the next video to learn what an AWS VPC is, and I'll see you there.